Hi guys, today we are going to continue solving system of linear equations. In this case, we are going to use a new method, Cramer's rule. In the previous video, I teach you how can you evaluate determinants. Now I'm going to teach you how Cramer's rule use the determinants to solve system of linear equations. Okay, then the first thing that I'm going to show you is Cramer's rule. Okay, then this is a given system. Remember, the variables for this system are x and y. Or letters in this case represent numbers. I provide in letters to provide the formula. Okay, then what is the formula? What is Cramer's rule? This is Cramer's rule. Cramer's rule, or according to Cramer's rule, we can find x value and y value finding some special determinants. Remember that when we are solving system of linear equations, in other words, we are finding the intersection point between the lines, and in other words, we are finding x and y. That is the coordinate for the intersection point. Okay, but according to Cramer's rule, x is we can find x dividing the determinant of x over determinant of the system, and we can find y dividing a determinant of y over a determinant of the system. Okay, but then we are talking about determinants to find x and y, but determinant about which matrix that I'm gonna show you. Okay, dx, or the determinant of x, is this matrix. You can identify the columns is ef and bd. dy, or determinant of y, it's the matrix is the first column is the first column for the matrix is AC, and the second column is EF. And the third, the determinant of the system, or just D, in the matrix, the first column is AC, and the second column is BD. But okay, if we are talking about matrices, how can we find these matrices? Okay, then I want you to be focused in the given system. Okay, because taking into account the given system, we can create, or we can understand or identify the each matrix. Okay, then I'm going to teach you first how can we find the matrix to find dx, or the determinant of x. Okay, if you can see dx, x, we are talking about x. Okay, dx, then dx, we can create a matrix replacing x column coefficients for the answers in the given system. Okay, then the column for x is not going to be the coefficient of x, it's going to be the constants, okay, or the numbers after the equal, in this case ef. And y column is still y column. Okay, now let's talk about the second matrix, dy, or the determinant of y. To identify the matrix to find dy, look at this. The first column are the coefficient for x, in this case a and z. That is the column for x. But in dy, change the column for y's. Then the column for y's are b and d, but in this this matrix, we'll replace that column for the answers over the constants e, f. Now, the next one is the determinant of the system. The determinant of the system are the coefficients for x column and for y column. Then the x column, AC, the y columns, the one column is B and D. Okay, then keep in mind the information because it's going to be really useful for you. dx, you take away x column and replace that column for the answers or for the constants, and you have to keep y column. If you are finding, or if you are talking about the matrix for dy, then you have to keep x column, and you are going to take away y column, and you are going to replace for the answers or for the constants, in this case ef. And finally, the determinant of the system is really simple because it is y column, x column first, and the second column is y column. I think it's very simple. Just keep that information in mind. It's going to be really useful for you. Okay, now let's analyze or let's use Cramer's rule to solve this system. Okay, this system is 2x plus 2y is equal to 121 and 24, and the second equation of the system is y minus x minus y equals 34. Okay, then let's start. The first thing, guys, we have to find three different determinants: the determinant of x, the determinant of y, the determinant of the system. Then first, let's start in order. Okay, then dx, we have to find dx, the determinant of x first. Then if you remember my explanation, dx, we have to find first the matrix and then the determinant of that matrix. Okay, then let's remember dx, then take away x column coefficients and replace for the answers or for the constants. Okay, in this case it's going to be the first column is going to be 124 and 34. Okay, the second column is y column, 2 and -1. Okay, then that's the first matrix. Now we have to find the determinant of this matrix, but the determinant is pretty simple. As I explained in the previous video, is the subtraction between the first diagonal and the second diagonal. Okay, then the first diagonal multiplication is -24. Of course, minus because it's always the subtraction between the diagonals, and the second diagonal is 34 times 2 is 68. Now this is subtraction. The answer is going to be -192. Okay. Now we have to find dy. Dy. Remember, you have to keep the column for x, or x column keep, and change y column for the answers column. Okay, then the matrix is going to be 1 and 2, that is the coefficient for x, or x coefficient for x column, and the second column is going to be the answers, 124 and 34. Exactly in the same way to find the determinants, then multiplying the first diagonal and the second diagonal. The first diagonal is 2 times 34 is equal to 68 minus, because it's always minus, and the second diagonal 124 times 1 is 124, and of course it's going to be equals to -56. Next determinant is the determinant of the system. Remember that the matrix for the determinant of the system is the x column and y column, then just the coefficient, of course. To find the diagonals, the multiplication of the first diagonal is -2, of course, minus, because it's always minus. Multiplication for the second diagonal is 2. -2 minus 2, of course, is equals to -4. Now let's remember what is the Cramer's rule. Cramer's rule is x, or to find x is dx divided by d. Okay, then let's replace just for the values. Dx then is going to be -92, and over d, in this case d is -4. That division is +48. Let's remember the second part for the Cramer's rule is y equals dy over d. Then let's replace one more time. Dy, of course, is -58 divided by d, then in this case is -4. Okay, that division, the answer, of course, is +14. Then we can conclude that our answer, the solution for this system, is the order pair 48 and 14. That is exactly the intersection point between these lines, or is the Cramer's rule. You can check replacing this answer in the original system, and you can confirm that this is real, or this is really the solution of the system. Or you can solve by any other method, and the answer must be exactly the same. Guys, this is Cramer's rule. Thank you.